think it started?
Looks like it has.
Uh, First of all, I would like to ask Uncle Bob that first of all, I'm truly honored and beyond excited to welcome legend in the world of software craftsmanship and someone whose work has shaped very foundation of clean and maintainable code that we guys write nowadays in our this generation. I give a very warm welcome to my very special guest, Uncle Bob, and it's an absolute privilege. Literally, your contributions to the field have inspired developers around the world, myself, including and many of my colleagues. Thank you for joining me today. I'm thrilled to learn from your insights and wisdom, Uncle Bob.
It's my pleasure, always.
Uncle Bob, I have many questions from my colleagues. They wanted to ask you, and nowadays everyone is talking about Uncle Bob a smart architecture. Like the architecture should be smart. So, what does smart architecture really mean to you? Is it more like about simplicity, scalability, or something else entirely?
Smart architecture. Huh? That's a term I haven't heard. But I assume it means intelligence in architecture. So the architecture of a system is the attributes that make the system easy to develop, maintain, and deploy. The purpose of architecture is to reduce manpower. That's why we do it. We put effort into the architecture and design of our systems in order to reduce the overall manpower required to develop, test, maintain, and deploy our systems. The principles that we use are the age-old principles of decoupling, cohesion, partitioning the system nicely, managing our dependencies between modules, and so on. This is very old, very old knowledge gathered by people from the 1960s, the 1970s, people like Tom DeMarco and Ed Yordan and Pete Code and Tim Lister, guys who were writing books about software when I was a little kid.
Yes, maybe. Thank you so much for your insights. This was a question from my colleague. Thank you very much. Okay, this is one of the this is another important topic that we at the company are discussing, and I really wanted to ask you, how do you see microservices when done right? Like, do they play a role in enabling faster innovation versus they create a friction or anything else? How do you see the microservices?
Well, first of all, the word micro, when put in front of services, was a very clever marketing trick. It got a lot of people very interested in service-oriented architecture once again. But let's just talk about what services are, whether they are micro or not. A service is just a set of functions that you can call remotely. It's really all it is. It might have a little bit of data behind it. So you might think of it as an object that you can call remotely. Now, the question is, why do you want to call it remotely? Most of the time, calling something remotely is really expensive. If you just wanted to call a function, why wouldn't you call it in your main program? Rather than trying to construct some horrible JSON string and then squirt it through a socket so that something on the other side has to reassemble it and then call the function. So one of the problems that we've seen over the last 10 years is that people have gotten very excited about partitioning their system into services when they should not. Now, there are times when services are useful. If you
Yes.
need to increase bandwidth or response time or certain security situations, then you do want services. But for the general purpose of putting a system together, services are just a big, slow impediment that get in the way of everything. They are not a means of decoupling. You must decouple in order to have services, but you do not need to have services in order to decouple. So many organizations have claimed that they use microservices because they're decoupling. They don't need to do that. They don't need to have that expense. So my advice for people who want to use services, micro or otherwise, is to be very careful. Make sure that you can afford the expense of transmitting all that data over a socket and possibly over a network connection. Make sure you can afford that. Don't separate things over a socket. Don't put a socket in between two things unless you absolutely need to.
Exactly. That's a very great answer. Only a legend can, like you, can answer like that, and very meaningful and very detailed. And thank you, Uncle Bob. And okay, this was the question one of my colleagues wanted to ask, that in many companies that resist architectural investment for the sake of speed, like how would you explain the long-term value of a more thoughtful design? Because they don't want to invest in their architecture, the things are going, so going. They say that okay, we have developed an architecture. Why would the clients would pay us again to correct our mistakes? Like they want to go on with that technical depth. So how would you say like that? Because they don't want to affect their speed.
There are so many things in that question. so
Yeah,
so let,
yeah,
let's
sorry.
start let's start with the beginning. Why would the customer know that you are spending time on architecture? Did you tell them this? Did you try to charge them for this? That's a big mistake, right? You don't want to tell your customer or your employer for that matter, well, first we have to start with the architecture and then later on we'll get into the code. You don't want to do that. First of all, you don't want to do that because that opens the door for the customer to say, well, I don't want you to do that, which is suicide.
Yes,
I mean,
this is a
you
society.
want you want a project to take a really long time and cost a really lot of money, you can just ignore the architecture and then see what happens. The other side of this, and this is very important, you don't want to do the architecture all up front. Architecture is something that evolves while you are implementing a system. You do a little bit up front, a little bit, and by a little bit, I mean a day or two or three, not a lot. Depends on how big the system is, right? And then you continue to do it and continue to do it as you gain experience with the system. I guarantee you that as you are writing the code of the system, you will realize that you made a whole bunch of architectural errors up front, and you want to be able to fix them rapidly. So architecture is something that happens while you are developing, not at the start only. A little bit at the start and then a great deal throughout. And you never tell anybody that you're doing that. It's just part of developing a system.
Exactly. Exactly. But sometimes it's not done right. Like in function, let's keep architecture aside. In function, you see 5,000 lines of code. But whenever a new developer comes in, he says, okay, my story is late due to that developer. It's done very bad coding. I don't understand this code, this bad code. Then it goes to company, the manager, why are not you removing this technical debt? And then manager goes to CEO. CEO says, okay, the company is not going to pay me anymore for your technical debt. So ask the developers to solve it or bear with it. I don't know. That's why. That's why.
Oh my goodness. first of all, managers shouldn't know anything at all about technical debt. It's entirely a technical issue
Yes,
and
exactly.
that programmers cause themselves, and programmers should fix themselves. It's never something you want to go to a manager. The programmer who goes to a manager and says, the reason I'm late is because of that guy, that's not someone you want to work with.
Yes. Yes.
You have to find a different place to work, and or find a way not to work with that person in any case, because that's really bad form. Um, you will make architectural errors, big ones, along the way. You'll start out, you'll think, oh, this will probably be a good architecture. We should do it this way, and you might draw some pretty pictures on a whiteboard or something, and then you will begin to write the code a day or two later. And within a week or two, you will realize that, yeah, that thing we had on the whiteboard is not quite right. We need to fix this. We need to fix that. That will happen throughout the project. You will be making these architectural errors. And what you want to do is be able to fix them as quickly as possible, recognize them as quickly as possible, fix them as quickly as possible before there is a million lines of code.
Yes.
Once you've got a million lines of code, it's really hard to fix architectural errors.
Yes. Then this would happen that I already mentioned one of my previous company that this case was there. So also it's I think it's common. And one of my friend wanted to ask you that do you think AI do you think AI assisted artificial intelligence assisted development will shift how we think about architecture or adopting and scaling? And secondly, they say that okay, considering the new AI tools, we are still learning how to code, like we are coding and how to use like better for these tools.
The AI tools are very impressive. I use them all the time now. Why wouldn't I? But they are tools. They are not intelligent. They are not. They're called artificial intelligence, but there is nothing intelligent about them. They are programs
Yes,
that you and I might write, and we should think about them as programs, and buggy programs at that.
yes,
So the AIs will produce code, and you must read that code. You must look at it. You must scrutinize it. You must take responsibility for the code that the AI generates. About 2/3 of the time, I throw that code away. It's useful in 1/3 of the cases, and I will modify it sometimes just a little bit, sometimes a lot. But about 2/3 of the time, I just discard it and say, no, that's dumb. And one of the reasons for that is that the AI cannot see architecture. The AI is not thinking about art. The AI is not thinking, period. But it's not
exactly.
considering architectural issues. So as I look at the code that the AI produces, I go, no, that's dumb. And then I write the code myself.
Yes,
I, I still use it because in those cases where I don't throw it away, it saves me a fair bit of time,
yes,
especially if there are repetitive things. If I have to do, a set of repetitive tasks, and I do the first one, and then it'll do the second and the third and the fourth, and I'll look at it carefully and think, okay, it did an okay job. All right. So it's a very useful tool, but don't trust it.
use it
Scrutinize
with
the hell out of it.
precaution. Yeah,
Yeah,
don't believe it. Okay? Yes, that's what
don't believe it.
that's what. Yeah,
Heavens no.
yeah. Uh, um, Uncle Bob, in my company, majority of the people are like playing with the legacy codes. Some of the teams are playing with the legacy code. So one of my colleague was saying that how to approach, how do you approach on a legacy project? Not always like testable, and how and introduce test. What techniques can we use to make it testable without big refactoring? I think this is almost question of everyone. Everyone has is facing this legacy code, and trying to be like make it not always testable. So they have this kind of challenges.
This is the problem everyone has.
Yes, yes,
Yep, we just had a brief dropout. I think everything's back. This is the problem that everyone has, and it is the most dire and difficult problem that we face. Most of us have very large legacy systems that were not tested, that have a poor architecture, and we want to get the benefits of a tested good architecture. But the path to gaining that is a long, hard road. There's no way that you're going to do this quickly. So, first bit of advice: do not start a project to fix this. Do not go to management and say, we need 3 months to revamp this code and make it better. Do not do that. You will fail. And when you fail, you will lose all credibility. You will never be able to do anything with that management again. What it requires is a change in attitude. It's a head twist. And everybody on the team has to agree. And the change is very simple, but it's very long term. Every time you check the code in, you check it in a little tiny bit better than when you checked it out. You don't do anything big. You do something small. When you're in a module, you're in that module to fix a bug or maybe add a new feature.
yes.
You will never make it worse. But before you check it in, do a random act of kindness. Just some little thing that's very low risk, make it a little better. And then check the module in. And then do that every single time. And if everyone on the team does that, then over the weeks and the months, parts of that code will get better. Not all the code, just the parts that you change a lot. And that's the most important stuff anyway. The stuff that you're changing a lot will get a little better and a little better and a little better. And maybe a month or 2 or 3 later, you will bring up a module that has been made a little bit better. And you'll look at it and say, I could add a test. Add one test. Check it in. The next person to come along, say, oh, I could add another test. Add that test. Check it in. Do this carefully. Do it slowly, bit by very slow, frustrating bit. That system will improve. The parts of the system that you never touch will not improve, but that's okay. You never touch them. Let them sit there in some horrible state. It doesn't matter. The parts that you are touching frequently will get better, and that will make your life easier and better. That system will never be perfect. It will never be a fully tested, fully clean, fully well architected system, but you can maneuver it into a state that is much easier to deal with.
Yes. What we shouldn't do is that commit to the management. Okay, I have Cam as a hero. I will do magic and I will write tests and clean it in 3 months. But rather we should work as a team to fix this bit by bit and steps by steps. Otherwise, we are not going to make it live. We shouldn't throw overconfidence over here. Thank you. Thank you so much, Bob. This was a very great answer. Okay, I have this question, but I don't understand this question properly. But maybe you can understand it. This was a question from my colleague. How you deal with the mixed code with infrastructure that is mixed everywhere and not pushed on the boundaries? Honestly, I don't get this question, but I can repeat it. How to deal with a mixed code with infrastructure that is mixed everywhere and not pushed on the boundaries? I think they might have been struggling with this, so they write the question, but I don't get the question.
There is a discipline which is infrastructure as code. And this is the idea that the deployment side of the system could be written as code. You could write code to deploy the system and govern all that rather than deploying the system manually. So it may be that that's what they're talking about. And maybe the idea there is that somehow the deployment side has gotten integrated with the business side and all of that code is mixed together. That, of course, is a very bad idea. if that's the situation they're in, they really do need to very gradually, using the same technique we talked about in the last one, very gradually start to separate those two and isolate the deployment code from the business rule code. That's my best answer to that question, which I may have completely misinterpreted, but that's the best answer I can give you right now.
All right, Uncle Bob, every one talks about TDD. Okay? As we all know that, all we know that everyone is curious, but you cannot implement it on your own. Like if no one, if you are curious, if not all the team members are curious, you cannot like. I think for me, I think but first, let me ask you a question that my colleague wanted to ask: how to approach a refactoring huge code base applying TDD? Because that one of my dad colleague is trying to refactor a huge code base, and he is really interested in TDD. But I think that if you are working in a team and you want to try TDD and no one else is, you cannot force anyone to work with you on the TDD. TDD can be your choice only. It should be your shift of mind and focus and your practice only. So what he was interested in how he's having this trouble. So how you approach a like refactoring a huge code base, applying TDD. Like this was his question.
Well, so half of that question was just the legacy code question again. Right. So half of that is you're going to have to go very slowly and gradually improve. You can't refactor without a suite of tests. You're going to have to get a suite of tests to clean things up very, very slowly. The other half of that question is a little more interesting, and that is, what if you are the only person on your team who's interested in doing test-driven development, TDD, test-driven development? And that's a very difficult problem to solve because you will write tests. You will practice TDD. You will write tests. But other people will then change your code and break your tests. And it becomes very difficult to live in that environment. And so what happens is there will be a divorce. If you are the only person on the team practicing test-driven development, you will leave that team. If there are 2 or 3 of you who are practicing test-driven development, and there are 2 or 3 that will not, those people will separate. This is a fundamental issue of values. And in a team, everyone has to have the same set of values. If you don't have the same set of values, there will be a divorce. And that divorce can be very painful. So be careful with that. You don't want to roar into a team as the one person who does test-driven development and tell everybody else that you're better than they are. You don't want to do that. If you are in that situation, you're going to have to live in that situation or find a better place to be.
Yes, I understand. Few people are those who leave the company just because of this culture. They don't apply testing. They don't apply. So they are not comfortable in this environment. So they leave the job despite how comfortable they are. I think we have a very less time. So I'm just quickly asking you questions because I know that we have a very less time. So this was one of my question from one of my colleagues, how to refactor to apply solid or patterns. This is what I wanted to ask from myself as well.
How do you refactor to apply solid and design patterns?
Yeah.
Okay, so these things, the solid principles and design patterns, For design patterns, what you will find is that as you're writing code, the code will begin to look a little bit like one of the patterns. And once it starts to look a little like one of the patterns, you can make a decision. Maybe I should make it look a lot like one of those patterns. And the reason that you would do that is so that the next person who comes along will look at that code and say, oh, I know what this code is. This is that pattern. That is the entire justification for design patterns. Design patterns allow one programmer to put the code into a form that another programmer will recognize. That's the whole justification. There is no value to forcing design patterns into your application. There is a lot of value in conforming your application to use recognizable patterns if those patterns apply. So you have to be very careful with design patterns. In the very early days of design patterns, a lot of people made mistakes. They would say, oh, everything must be a pattern. I must use the composite pattern. I must use the visitor pattern. I must use the decorator pattern. And no, you don't. Right? Instead, you will write your code normally, and then you will recognize, oh, this is starting to look like a strategy pattern. I should name it strategy, and then I should conform to the form in the design patterns book. That's how we should be using patterns. Solid principles. Solid principles are they're things that you look at as you are writing the code. As you're writing code, as you're designing and writing code, you look at this code and think, well, did I make it open for modification? Did I close it against changes, but did I allow it to be extended? The open close principle. Did I close it for modification, but is it still extensible? That's a question you can ask yourself as you are writing the code or after you've written it and you decide to refactor it a little bit. Whenever you create an inheritance hierarchy, you can look at it and say, did it really conform to the Liskov substitution principle? Have I created derivatives? Have I created subclasses that my clients aren't going to recognize? Those are questions you can ask yourself. All the principles work that way. They are questions you can ask yourself after you have begun to write the code, or even after you have finished writing the code and all your tests pass. And then you can ask yourself, I wonder if I conform to those principles. What you will find over time as you get used to this is that all becomes just part of the normal way of thinking about things. Right? It almost becomes instinct, right? As you're writing the code, you've gotten used to it, and it will be open and closed. It will conform to the Liskov substitution principle because those ideas are in your brain. They finally kind of gotten wired in. And then when you're done, you'll look back and say, the open close principle is fine there. And, Liskov is, it's fine. That's how it works. But it takes a long time to get those neurons wired.
This is the best definition, and really, it's really you. I want to be like you, like how you think.
See this gray hair? That's how long that takes.
Literally, the guys who will be watching this podcast will wish the same, because I really, when you say that, okay, this is in your instincts, start thinking that way. Start asking yourself questions. This is very, very great answer, Uncle Bob. And we truly wish that we start thinking like you. The way you presented it was really, really great for me. It's my last question that is written by me. It was related to one of the business problem I was looking. I was like finding in the project. So I thought, why not to ask your suggestion? This is just my question. It's not like uh, I'm not the one who will architect the system, but this was the thing that I that came to my mind. So I thought, why not to discuss with you? So, Uncle Bob, in many enterprise applications, teams build a core product. Usually, they start a core product, and that was support their dozens of clients, and each with their unique needs. And over the time, this often leads to maintaining multiple customized versions of the same product, which results in high deployment costs, brittle releases processes, and very costly increased technical debt. From an architectural standpoint, how would you recommend designing such kind of systems in a way that supports client-specific variations while preserving a single product core? Ideally, like being clean, scalable, and maintainable, just like your principles. Would you lean towards a plugin architecture or configuration or customization, or something else entirely to strike the balance between this? Because at the end, after many years, you find out, okay, you have a core product, but you have 50 different customizations of the same product. It's difficult to manage releases, and for the clients, when they want to upgrade, this is very costly for them as well. How you see it? This is one of my last question that was totally from me.
Well, it's a difficult problem to solve, and everyone wants to solve this problem because everyone has this issue. We would like to be able to deploy to 5 different customers, but those 5 different customers have 5 different sets of requirements, even though there is a common base of behavior. Now, I have done this a few times, and it has never been easy. And let me tell you the story of one of those times. And this was 30 years ago. Yeah, that's about right. 30 years ago. And my team and I were developing 18 different applications, but they all had a common base of behavior. And so we thought, we're going to write the best framework in the world. We are going to use object-oriented principles, and we will make a reusable framework. And we worked for a year on this reusable framework. And we got one application done. And it worked, and it was great. And we said, okay, now we can do the next 3 applications. And we hired a couple of people, and we started working on those 3 applications, and it was an utter disaster because that framework was not reusable for those 3 applications. And within 2 weeks, we stopped and said, wow, we have screwed up. We have blown a year. We need to regroup. And so what we did the second time is we said, okay, we're starting over. The 3 applications we are going to develop at the same time. Nothing goes into that framework unless all 3 applications agree. And that was a lot of work, right? Twisting and turning and trying to get it all to work. And that took another year. At the end of that year, we did 3 more. They were done in 2 months. Then we did 3 more. They were done in 2 months. Then we did 3 more. They were done in 2 months. So it worked the second time. The moral of that story is that our brains are too small to think about all the problems of all those customers who are going to want to use our systems. So if you can get a representative sample of those customers and develop for them simultaneously. If you can. If you can't, then follow the original plan that I followed. Write your code for the first customer. Try to separate as much as you can, and then expect a lot of trouble with the second customer. And when you expect that trouble from the second customer, integrate that into your framework so that you're not just writing a brand new application. Expect that to take almost as long as the first customer. Then do the third customer and expect that to take a little less time. And then the fourth, a little less time. And then the fifth, you'll probably have it going pretty well by then. But those first 2 are going to be hell.
Okay, I think this was a golden advice for me who was thinking this problem in such a way. And I will be noting down every point you told me from your experience. I really, really, really I'm really thankful to you, Uncle Bob, because really, honestly, your work is not just inspiring for all of us. If I talk about my company, it's a very big company doing great things, but it's very much inspiring for all of us. And in today's fast-moving world of development, the principle do you design are a must because they really bring clarity in our work, discipline, and long-term thinking that we desperately need in today's era. And we really appreciate you that you shared everything with the community. And most important is that you are very humble. Like you are in a very you done a lot for the people, the world. What is always going to remember your efforts. But thing is, you are humble. Uh, Even I'm calling you for the fourth or fifth time, but I never. You always came and answered our questions. That for me, my colleagues, my company, or people juggling with the daily problems. But one thing I would like to say from everyone of my surroundings that we really want to become like you. So, but I know things come from experience, but what we do think we do practice your laws, we do practice your things, but how like any advice for us because what advice would you give us because we really want to become like you. Everyone is so inspired from you. We don't know how to become Uncle Bob.
How do you become like Bob? Um,
No, it's not possible, but at least we start thinking like Uncle Bob. That's enough for us.
you really don't want to be like me. You want to be like you. And you want to be like you and gain as much knowledge and skill as you can. This requires patience, and you're going to make mistakes. You're going to learn from some of the mistakes you make. That's okay. And you can listen to guys like me, and maybe I can help you avoid some of the smaller mistakes. But get to be about my age, and you'll look back and go, yeah, I think I know a little bit about this, tiny little bit.
That's why we all people always pray for your health and for your well-being, for your health, and
I appreciate
I
that.
I we had a meeting on 6th May. I didn't hear from you. That hadn't happened before, so I was very worried about your health and your well-being. So I thought Uncle Bob never misses this session. So I really prayed for you and all of my people. We all over the world are your fans, and I can't thank you enough. You came to you got some time for us and answered our question. That question from many people, so they are going to help many people in their many problems. So definitely when we will be hearing from you directly from you, there is 100% chance that we make less mistakes.
Well, let's hope.
Yes, yes. So I think thank you, Uncle Bob. I know your time is very precious, and you already told me you have other commitments. So I really thank you for the session.
Oh, you're very welcome. It's always my pleasure, and thank you for inviting me.
I stopped the recording, Uncle Bob, but on